Hello, hello, hello. Hopefully we're all doing good. Today's video is going to be on section 1.2, which is all about functions. It's a little bit longer of a section, but we should have most of this knowledge already, so it'll be a little bit of review as well. But we're going to start with our 4 objectives. The first objective is determine whether a relation is a function. So is it a function? Is it not a function? And we'll talk about what the difference is. Then we're going to use function notation. That's our f of x, right? And we're going to evaluate different functions. We're going to find the domain of functions. So a quick review of domain there. And then we're also going to evaluate the difference quotient. So the difference quotient that is the only thing that is new in this unit. Everything else should be relatively familiar. Okay, so we're going to start here determining whether something is a function. So in a relation, the x coordinates are called the domain. So when we're looking at our domain, right, any x coordinate is part of the domain, and then the y coordinates are part of the range. So when we think back to like algebra 2 or whatever, right, domain is how far left and right does it go, and then range is how far up and down does it go. So something is a function if one number in each domain, I guess, so like one number in the domain goes to one number in the range. So if I have an input, so an x value of 2, I cannot have an output of 4 and 7, okay? If I have an input of a number, I can only get one output. So that's going to be our like main definition of a function, is that if I plug in one number, I can only get out one number. I cannot get out multiple numbers. So that's going to be kind of key here. So when we look at these first two, actually, I'm going to keep going. So here's my inputs, here's my outputs. So here I want to know whether or not is it a function. Well, 7 only has one output of 3, and that's okay. -2 only has one output of 4. That's good. And then 5 only has one output of -8, and that's okay. So yes, this is a function. So function. Okay. Over here, 6 has an output of 5. That's good. -8 has an output of 9. That's fine. But 0 has an output of 5 and -4. It's okay that both 6 goes to 5 and 0 goes to 5. But since 0 also goes to -4, this is not a function. Not a function. So really the key here is that, I'm going to make a little note. No, wow, that's not how you spell no, huh? No one x value can have 2 or more y values. 2 or more y values. Can't have it, okay? So one x value goes to one y value. If you have multiple x's, they have to have the same y. So we're going to look at some other examples here. I'm going to scroll down. So 1x goes to 1y. So like for C and D here, let's just look at C and D. So here I'm looking at my x's. I have 1 to 1, my input, right? An input of 1, an input of 3, an input of 5, and an input of 5. Since I have a double input here, that's okay as long as it goes to the same output. But here 5 goes to 6 and 5 also goes to 8. So this is not a function. Can't have it. Not a function. Okay, because 5 is going to 6, but it's also going to 8. And you can't have that. Over here, let's see, I have do I have any repeating outputs or inputs, excuse me, 1, 3, 6, and 8. So since none of my x's repeat, this is a function. And this is when I get a lot of questions about, but 6 goes to 5 and 8 goes to 5. So 6 goes to 5, but 8 also goes to 5. That is okay. Okay, so this is okay. You are allowed to do that. Okay, you can have multiple x's go to the same y, but you cannot have one x go to multiple y's. So if there's any x values that repeat, you need to check, and if their y values are not the same, it is not a function. Super, super important, okay? So let's look at our next example here. Just a quick review. Okay, so this says determine whether this relation is a function. So I'm looking here. My input is x. My output is y, obviously. So I'm looking, and I have a repeat of x's here and here. Here 2 goes to 11, and here 2 goes to 10. So this is not a function. Can't have it. Okay, 2 is going to 11 and 2 is going to 10, and that's no good. You don't have to draw this part. I'm just trying to draw it as visual. Over here, okay, so then I asked myself, I can't have, let's say, a 4, right? I can't have 4, 2, and also 4, -3, because that would be, right? That would be repeating myself. So I cannot have 2 points that are exactly vertical of each other. So then this is where the vertical line test comes in. So hopefully you remember the vertical line test. And it says if I draw vertical lines anywhere along my graph, in this case I'm only drawing them through the points that we have, does it touch more than 1 point? So here on this vertical line, I only go through 1 point, right? This one, -2, 3. This one, I only go through 1 point, -1, 0. 1 point, 1 point, 1 point. If there were another point like here, then it would not be a function. But since I only touch 1 point at any given time on those vertical lines, this is a function. So we can say, if it helps, there's no points exactly vertical. Okay, so the vertical line test is very helpful here. Vertical line test. So hopefully we'll remember that. Okay, so that's just a quick, like, what is a function, right? If I have x's that repeat and go to different y's, then it is not a function. So I'm going to go ahead and erase this. And we're going to say, okay, from a graph or from a table, I can probably determine if it's a function or not. But what about if I'm doing it from an equation? So that's what we're going to look at right here. Okay, is how do I tell if something is a function in an equation? So the first thing that you're going to want to do is you're going to want to solve for y. That's going to help you a lot, okay? So whatever the equation is, you're going to want to solve it for y. So let's go ahead and do this one first, maybe. So I'm going to subtract x squared. So I get y is equal to -x squared plus 1. So there, I've solved for y. Now my question is, if I plug in a number for x, how many numbers do I get out for y? So I'm going to pick an easy number, 1, right? 1 squared is 1, times -1 is -1. -1 plus 1 is 0. So if I plug in -1, if I plug in 1, I can get out 0. So let's try plugging in another number. For example, let's do 2. right? If I plug in 2, 2 squared is 4. Then with the negative, it's negative 4 plus 1, I get negative 3. There's no other number that I can get besides negative 3 if I plug in 2. Okay, so since every number I plug in only gives me one unique number, this is a function. So that is a function. Versus over here, so let's solve. I'm going to add the x to the other side. So I get y squared is equal to x plus 1. Now I have to take the square root, right? Because I need to get the y by itself. So I'm going to take the square root. And don't forget that when you take the square root of something, you need plus or minus, right? The square root of x plus 1. So now we're going to plug in numbers. Let's say 3. 3 plus 1 is 4. The square root of 4 is 2. But I have positive 2 or negative 2. So I actually get 2 answers here. So if I plug in 3, I get out 2 possible answers, and that's not okay, right? If I plug in 3, I could get out 2, or I could get out negative 2, and that's not okay. So this right here, so whenever you have that plus or minus, it's not going to work for you. That's not okay. So this is not a function. Okay, so go ahead and pause the video, try C and D, and then when you are ready to check your work, go ahead and just hit play again, and I'll see you in a second. Okay, so hopefully your first step for C was to solve for y, and this is what we get when we solve for y. So when you start thinking about values, if I plug in a 1, I'm going to get out 4, and that's my only option. If I plug in 0, I'm going to get out 6, and that's my only option. So every number I plug in gives me one unique answer. So that tells me that this is a function. Okay. And then over here, if I solve for y, I should have gotten y squared is equal to negative x squared plus 9. And then when you take the square root, I get y is equal to plus or minus the square root of negative x squared plus 9. And again, I have that plus or minus right here because I'm taking the square root. So that tells me that this is not a function. And I get a lot of questions about, well, can't I take the square root of x squared and the square root of 9? And the answer is no, you can't break up this square root like that. This is all connected in one parenthesis. So it is all one piece. So you cannot just take the square root of each piece. Okay, so hopefully that's making sense. If you get this plus or minus, it's not going to be a function. There are going to be other things that we get to that aren't functions, but for now, that's pretty much going to be it. Okay, so real quickly, we're going to move on and talk about just function notation and just basically like what is a function, right? We already figured out how to find if something is a function. If something is a function and you have an equation, let's say like this, you can write it then in function notation. So function, we usually use f, right? This f of x, this is our function notation. That's what's used most often. This tells me that the name of the function is f. I can name a function anything I want. I can name a function g of something, right? I can name it h of something. It doesn't matter. Whatever we want. So this number out here, this is the name of it. Then the variable on the inside, that's what variable has to be in the equation. So if I have an x in here, my equation has to have an x. Okay, if I have a y in here and my equation has an x, that doesn't make any sense, okay? Because this tells me that the variable should be a y, okay? And then this is read f of x, so make sure that it's not fx or anything like that. It's f of x, and it's just another name for y. So this is my output, x is my input. So when we're evaluating these functions, when we're plugging in numbers, all we have to do is replace our variable with whatever number it is that we're substituting. So let's look at that. Scroll down a little bit. Oh, we missed this little part. Okay, so the variable, so x, when you have x, the input is called the independent variable. The independent variable is the input, and then the output is the dependent variable. So that just means the independent variable, you can pick what to put in, right? So it's independent, and then what you get out depends on what you put in. So since what you get out depends on what you put in, it's the dependent variable. So when we're looking at these, this should go pretty quick. This is a nice little review for us. All this is saying is in the g function, which is right here, and I know that's the g function because that's the name, what do I get if I plug 2 in for x? That's all it's saying. So this is g of 2 is how you say it. And then I'm just going to plug in 2 for x. So I have negative 2 squared. Remember when you plug in a number, you almost always put it in parentheses. So I just plug it in. So g of 2. Now when you do this, you have to make sure you square this first. So 2 squared is 4, but then this negative comes down. So this is actually negative 4. Okay, so it's 2 squared first, then the negative. Plus 4 times 2 is 8. Plus 1. I'm going to keep going. Negative 4 plus 8 is 4. Plus 1. I get 5. So it's really important that your final answer have g of 2 equals 5. And the reason for that is this is like a whole mathematical sentence. You're basically saying if I plug 2 into the g function, I get out 5. And that's it. Let's look at b. This is g of t. So this is just saying, hey, every time I see an x, I'm going to replace it with a t. So I have negative t squared plus 4 times t plus 1. And I can't do anything else, right? Like I don't know what t is. I mean, the only other thing that we could really do is simplify this and kind of get rid of the parentheses and just make it negative t squared plus 4t plus 1. That's the only other thing that we could do because I don't have a value for t. But all you're doing is you're replacing all the x's with t. Same thing here. We're replacing all of the x's with x plus 2. And I'm going to erase those two just so I have some more room here. So g of x plus 2 is negative x plus 2 squared plus 4 times x plus 2 plus 1. Okay, now super common for us to go, oh, well, this is x squared plus 4. And if you do that, I'll lose my mind. And it means that you're killing a puppy. And if you don't know what that means, there's a poster in my classroom that says if you do this, you kill a puppy. So the only thing that you can do here is that negative can come down. You can write this x plus 2 twice. That is x plus 2 squared. Okay, I'm going to go ahead and distribute this 4 to give me 4x plus 8 plus 1. But that's all I can do so far, okay? Now, again, ignoring this negative, I'm going to go ahead and distribute out this x plus 2 and x plus 2. So x times x is x squared. And then I have plus 2x plus 2x plus 4. I still have this plus 4x, and then 8 plus 1 is 9. So now I can distribute this negative. So that gives me negative x squared. 2x and 2x is 4x, so I can just make this a negative 4x. And then negative times 4 is negative 4. Plus 4x plus 9. And then fun stuff happens here. The negative 4x and the positive 4x cancel. So I have negative x squared. And then negative 4 and 9 combine to 5. So g of x plus 2 is equal to negative x squared plus 5. So just plugging in those values and being really careful with distributing and making sure that we're going in the right order here. Big note here is that g of x plus 2 is not the same thing as g of x plus 2. Okay, so if this plus 2 is outside the parenthesis, all you're doing is taking your g of x, which is negative x squared plus 4x plus 1, and you're just adding 2 to the end of it. So clearly that is not the same thing as this. So just be really, really careful with that. Okay, so our extra examples here, I want you guys to give these 3 a shot, and then we will move on to piecewise functions. So go ahead and hit pause, and then I'll see you in a second. Okay, so I want you to check your answers here on D, E, and F. For D, we're just plugging in negative 5. So negative 5 squared is 25. Negative 7 times negative 5 is 35. And then I just added them all up to get 63. So F of negative 5 equals 63. For E, it was a lot like C up above. I have x plus 4, but that's being squared. And then minus 7 times x plus 4 plus 3. So I wrote out my x plus 4 twice because that's what x plus 4 squared is. Then I distributed this negative 7, so I got negative 7x minus 28, and then plus 3. X plus 4 times x plus 4 gave me x squared plus 8x plus 16, minus 27, and then minus 7x minus 25, which I got from the negative 28 plus 3. And then the last thing was I combined like terms. So f of x plus 4 gave me x squared, and then 8x minus 7x is 1x, and then 16 minus 25 is negative 9. And then last but not least, f of negative x. So this just means whenever there's an x, I'm going to switch it for a negative x. So this gave me negative x squared minus 7 times negative x plus 3. Well, negative number squared is still positive, so that stays x squared. And then negative 7 times negative x is positive 7x, and then I have the plus 3. And I can't combine anything else after that. So then that would just be my final answer there. So hopefully evaluating functions, you feel good about this. A little review. Stuff like this, I did not mean to do that, sorry. Stuff like this maybe is a little bit new, but the actual math behind it isn't. Like, we all know how to FOIL and distribute this out and combine like terms. So reach out if you guys have any questions, and we're going to move on to piecewise functions. And we're going to talk about piecewise functions a little bit. Can I fit this all onto one page? I think so. Let's do this. Okay, so a piecewise function is 2 or more equations that are combined into one graph. So sometimes the graph can look a little funky, a little weird, because maybe you have like half a parabola and then a line or something like that. But all it is that multiple different equations that are kind of smushed together and combined together. So here we do have the graph, and this should have arrows. Sorry, that continues on forever. We have a graph of absolute value. So absolute value, we know, starts at 0, goes up 1 over 1 in both directions, and it just makes that perfect V. Okay, but absolute value is actually a piecewise function. So what this is saying is from when x is 0, so I'm going to be doing a lot of drawing and then erasing, so maybe just watch first. Okay, when x is 0 or bigger, I'm going to graph the equation y equals x. Well, y equals x, I know starts at 0, goes up 1 over 1, but it also goes down 1 to the left 1, right? So this line right here is the line of y equals x. However, I'm only interested when x is greater than or equal to 0. So anything over here, I don't care about. I am not interested in that at all. I'm only interested from 0 on. So that is why I only see this much of it. And that's why I don't have any of this stuff down here. Because I'm only interested in that graph from 0 to infinity. So just this section right here. Okay? And then it says, okay, well, when x is less than 0, so anything over here, I'm going to graph the equation y equals negative x. Well, y equals negative x starts at 0 and goes up 1 to the left 1, right? And it continues on in both directions. So this line right here is the graph of y equals negative x. But I'm only interested in that graph when x is less than 0. So anything greater than 0, right? Do you see how on the x-axis, this number 1 is greater than 0, 2 is greater than 0. So those numbers, any value here or here or here or here doesn't apply. So if I have that line again, this value has an x value of 1, but I don't care. This point has an x value of 2, right? This point has an x value of 3, but I'm only interested in x values from less than 0. So I'm not interested in these at all. And so then what that does is that creates this absolute value graph where the right-hand side of the y-axis is one graph, it's y equals x, and then the left-hand side of this graph is the other line, y equals negative x. So we're going to look at, okay, what can I do with these functions, right? So let's just look at example 4. It says evaluate when x is negative 1 and when x is 0. So I am interested in f of negative 1. That's what I want, right? I want x to be negative 1. So I have to look here first and see when is x negative 1? So here, x's are less than 0. Well, is negative 1 less than 0? Yes. So that tells me I'm only going to use this function. So I'm only interested in, so at negative 1, I'm only using that top function because negative 1 does not apply here because this is only for numbers bigger than or equal to 0. Okay, so any x value that's smaller than 0, I have to use this top equation. And I'm just going to simplify, right? 1 squared is 1 plus 1. So f of negative 1 equals 2. So on this graph, f of negative 1 is 2. Then it wants me to find f of 0. So then now I have to figure out which one of these can I use for 0. Here, this is only when x is less than 0. But this bottom equation I can use when x is greater than or equal to 0. So I'm actually going to use this bottom equation now, which gives me 0 minus 1. So f of 0 is equal to negative 1. Oops, I don't want to open my grade book, especially not an old grade book. Okay, so hopefully we feel good about that. So really just the trick is whatever number you're plugging in, you have to check to see which equation am I allowed to use that number in. Okay, so like if I was plugging in 4 into here, I would only be able to plug it into this bottom equation because 4 is greater than or equal to 0. If I was plugging in negative 20, I would only be able to use this top equation because negative 20 is less than 0. So you just have to find which equation you're allowed to use. Okay, so now for the extra example, I want you guys to try this. Make sure you're paying attention here. Which equation am I allowed to use at negative 5? Which equation am I allowed to use at 6? So go ahead and give it a shot. If you mess up, that's fine. That's great. It's better to try and mess up and learn from your mistakes than to not try at all. So I really do want you to give this a shot. So go ahead and hit pause, and then I'll see you in a second. Okay, so let's go over these guys. So what we're looking at here is f of -5. So I need to figure out which of these two functions I'm allowed to use at -5. So -5 is less than 0, so that tells me I'm going to use this top equation. So the x squared plus 3. So I'm going to plug in -5 into that top equation. Well, -5 squared is 25, all right, plus 3. So f of -5 is equal to 28. So hopefully you got that, and it looks all good and everything. For the second one, f of 6, so where does 6 belong? 6 is greater than or equal to 0. So I'm going to be using that bottom equation. So that gives me 5 times 6 plus 3. 5 times 6 is 30 plus 3. So f of 6 is equal to 33. Hopefully you got those and you're feeling confident about that. Just making sure you find which equation you're allowed to plug your number into. Okay, well, let's just cruise on along here. Almost the second to last thing that we're going to look at is we're going to review domain. We're not going to talk about range quite yet, but for now, we're just going to review domain. So domain is any value along the x-axis that works for the equation. Okay, so any number that you are allowed to put into the equation, if it's an equation, or any number that you are given in the x values, things like that. Remember things that you're not allowed to do. You're not allowed to, as it says here, you're not allowed to divide by 0. So if you plug in an x and that causes you to divide by 0, you can't do that, okay? You also cannot have negative numbers under a square root. So if you plug in an x value and it gives you a negative number under the square root, that's not part of the domain. You can't have that. So let's look at example 5. We're going to do 5 examples here together, and then you guys are going to try some on your own. Okay, so the first one, I'm just given 5 points here. So when you're just given points, you're not assuming that those points are connected in any way. So you'll just write your domain in your Batman brackets and try to write them in numerical order. So I'm only looking at the x values here. Luckily for us, they're already in numerical order. So -3, -1, 0, 2, and 4. And that's my domain. That's it. So domain, right? Here you don't have to write repeat numbers. Don't write repeat numbers twice. Okay, so if you have something, if you have like 2 twice or 4 twice, you could only have to write it 1 time. You don't have to write it 2 times, okay? So let's look at B then. B is an equation, so I have to ask myself, is there anything I'm not allowed to plug into this equation? So looking at it, are there any numbers here that I'm not, can I plug in negative numbers? Yeah, right, I can plug in -4, whatever, any negative number I want. Can I plug in 0? Sure, I get 5. Can I plug in any positive number? Yeah, I can plug in decimals or whatever. So since I can plug in any number I want into this equation, we say that x is in the set, remember this, of all real numbers. So that's one way you can write it. Okay, you also can write that the domain is from -infinity to infinity. So that's another way you could write it. Or you could write that the domain goes from -infinity is less than x is less than infinity. Multiple ways to write it. This is the one that I prefer. It's the one that you're going to probably see most often. But if you forget all these like crazy symbols, then you can go ahead and write it in interval notation like that. So again, you do not have to write it in all three of these ways. Just pick one. Okay. For C, I see I have a fraction here, and so that gives me a red flag, and that requires me to remember I'm not allowed to divide by 0. So what value of x would give me 0 on the bottom of the fraction? And hopefully you thought -5, right? If I plug in -5 plus 5, I get 0, and then I get 1 over 0. But I can plug in any other number I want here. I can plug in negatives, positives. I can plug in 0, right? If I plug in 0, I get 1 over 5. I can plug in any number I want except for 5. So what that looks like is we can say that x is in the set of all real numbers, but x cannot equal -5. So that's one way to write it. I would probably stick with that way. The other ones I think are just a little bit more confusing. So we say x can be any number we want except for -5. Okay, for D, we're given not just an equation, but we're given the context of the equation. So this is volume. So thinking about the volume of something, right? What's the smallest volume that we can have of something? And so we should have thought that we can't have negative volume, right? Can't have negative volume. So what that tells us is the lowest I can have is 0, right? So R, if R is 0, 0 cubed is 0, 0 times pi and 4/3 and everything is 0. So R has to be greater than 0. Okay, R has to be, the radius, that's the radius of a sphere, has to be bigger than 0. If R is 0, then there is no object, there is no volume. So I can't have an or equal to either. It has to be greater than 0 at some point. So I can write it like this. I can write that the domain is 0 to infinity. Right, I can write that the domain is 0 is less than R is less than infinity. Okay, but this is kind of a little bit shorter. Okay, and then the last one, E, I have this square root, so hopefully automatically I get this idea that I'm restricted by a square root because I'm not allowed to have a negative number. Can I have 0 under a square root? Yes, I can, okay? So whatever is under here, in this case it's 4 minus 3x, but whatever's under the square root, it has to be bigger than or equal to 0. I don't have a choice. It's my only option, right? It has to be bigger than or equal to 0. So I want to figure out what x is, right? So if I solve this equation, I'm going to add the 3x. So I get 4 is greater than or equal to 3x. Divide by 3. So I get that x has to be less than or equal to 4/3. Okay, so 4/3 is the biggest number I can have. So I can leave my answer like this, or I can write negative infinity to 4/3. That's okay too, keeping in mind that 4/3 would need a bracket, while negative infinity has a parenthesis. So either one of these two answers I'm fine with. If it asks you for a specific notation, then you'll have to know which one is which. But for now, if it doesn't ask you, if it just asks you to find the domain, sorry, this should say domain, then you can pick either one of these two. So again, we're going to pause. There's 3 examples here that I want you guys to try. And then when you feel like you're ready to check your work, or if you need a little bit of a push, you can go ahead and hit play, but go ahead and give that a shot first. Okay, so for the first one, hopefully we saw that x is in the set of all real numbers, right? I can plug in any number I want in here. And I want to go over these other two with you, so if you got a little stuck on them, that's okay. Here I know that this cannot equal 0. So I'm just going to write a little cannot equal 0. The top can be anything I want because I can have 0 on the top of a fraction, just not the bottom. So the easiest way to do this is to factor the bottom. And so hopefully we're up to date on our factoring skills. If not, that is definitely something that you're going to want to get brushed up on because we're going to be factoring a lot, okay? So when I factor the bottom, the top just stays 6x, but the bottom factored is x minus 3, x plus 3, or if you did the plus 3 first, the order doesn't necessarily matter, okay? And so all I know is that any number that gives me 0 on the bottom, I can't have. So I'm going to go ahead and say that x is in the set of all real numbers. And then I'm going to say that x cannot equal, and then let's look. So what value here would give me 0 in this parenthesis? And hopefully you said 3, right? 3 minus 3 is 0. And then over here, what value would give you 0? And that answer is negative 3. So that's what you're looking for in your domain. So any number that you want except for 3 or negative 3. Again, the top can be 0, just not the bottom. And then the last one, because it's under a square root, right, I know that it has to be greater than or equal to 0. However, because it's on the bottom, it cannot be equal to 0. So that tells me that whatever's under the square root, in this case it's 3x plus 12, has to be greater than 0. I cannot have an or equal to underneath. Because if it's equal to 0, then I'll get 0 on the bottom of the fraction, and I can't have that. So if I solve this, I get 3x is greater than negative 12. Divide both sides by 3, and I get x is greater than negative 4. So again, you can leave it like this, or I can say, hey, anything from negative 4 to infinity, and negative 4 would have to have a parenthesis since I cannot be equal to negative 4. So hopefully that feels good. Even if we just need a little bit more practice, you will get practice on that on the homework. So don't stress. But if you do need help on that, please make sure that you reach out right away. And the next problem that we're going to look at, let me double check real quick. Yeah, the next problem that we're going to look at requires that you have a graphing calculator. So I'm just going to stress again, if you don't have your own graphing calculator and you want one, that's yours that you can keep, please reach out to me because I do have a sponsorship where I can get a couple calculators to people, or I can check one out to you for the year and things like that. But you will need your own graphing calculator throughout the year. So I'm going to go ahead and scroll down, and we're going to look at these problems. Okay, so example 6 says use a graphing utility, which is a graphing calculator, to find the domain and range of the function. So we are going to go ahead and pull up this on our graphing calculator, and hopefully it won't take too long. So let me get my calculator going, and I'll be right back. Okay, so let's pull up my graphing calculator here. And it wants me to graph the function, so I'm going to go into y equals so I can graph it. And it wants me to graph the square root of 9 minus x squared. Now again, this is something I could figure out the domain on my own, just probably by thinking about it a little bit harder, but it wants me to specifically use my graphing calculator. So then I'm going to go ahead and hit graph, and this is what it looks like. So even if we were to zoom in a little bit, I know it looks like it's not touching here or here, but it actually does. So the furthest left I go is negative 3, and the furthest to the right I go is 3. So that tells me that my domain is negative 3 to 3. And then the question is, can I actually have negative 3 and 3? And the answer is yes, so that is brackets. You also could write this as negative 3 is less than or equal to x is less than or equal to 3. So that's another way. And then our range, so if I go back to my calculator, the range now is up and down. So what's the furthest down it goes? Well, it doesn't go any further than 0. And the furthest up it goes is 3. So what it's saying is, what's the smallest number I can get out of the equation? What's the biggest number I can get out of the equation? So here, my smallest number I can get out is 0. My biggest number I can get out is 3. Can I actually have 0 and 3? Yes. So that is how I'm getting those. So again, you could write it 0 is less than or equal to, in this case, because it's range, it's y, so make sure you pay attention to that. Okay, so go ahead and real quick try the extra example. If you have a graphing calculator, do it on there. If you don't, you can probably just figure it out by looking at it. And then let's check in. Okay, check your work here, make sure it all looks good. I do just want to point out one thing real quick. You do not have to write both of these. Okay, you can just pick one. Personally, I go with this, but you do not have to write both. You can just write just these two, or you can write just these two. Okay, so I'm just showing you two different ways of writing it. So again, if you're struggling with this, please make sure you reach out. We have one more thing we're going to talk about. We are going to actually skip these application problems, and we're going to go right into the difference quotient. So the difference quotient is probably going to be the only thing that's new. None of it, like the math of it, is not confusing. Well, whatever. But the math of it is nothing new. You guys know how to solve all of the math of it. It's just the organization that's a little bit tricky for people. So I'm going to go ahead and clear this, and we're going to scroll down. We're going to skip these application problems, and we're going to look at the difference quotient. So difference quotient is used in calculus, so it makes sense that in pre-calc we would be reviewing this and making sure that we understand how it works. All it's saying is, right, earlier in this lesson we looked at, hey, if I have a function f, I can replace it with x plus h, right? Like I can plug in x plus h whenever I see an x, and that's no big deal. And I know what f of x is always the original, right? And then h is just a variable. And the only thing is that h cannot be 0 because I cannot have 0 on the bottom of a fraction. So this is a very special definition that's used a lot in calculus. We want to make sure that we're exposed to it at least a little bit. So what I'm going to do here is I am going to do my very, very, very best to write small and neat and with enough space so that we can get through this one problem all on the screen. Okay, so this right here, this is just telling me what to do. Okay, so I'm just going to look at this piece first, right here. This just tells me I'm going to, anytime I see an x in my function, here's my function. Anytime I see an x, I'm going to replace it with x plus h instead. So I like to do that whole first part in brackets. So I'm going to do, instead of x squared, it's x plus h squared. So I replaced this x with x plus h. That's what it told me to do. Then I have minus 4 times, instead of x, it's x plus h. Then I have plus 7. So that's that whole first part, that box that I just circled. Okay? So all I did was went through my equation and I replaced x with x plus h, and replaced x with x plus h. Then it tells me to subtract, right here, subtract. And then it says subtract f of x. Well, f of x is just the original equation. So I'm just going to subtract the original equation, which is x squared minus 4x plus 7. Okay, so all I did was subtract the original equation. And then it says that whole thing is all over h. So this does, like it's a lot, right? It looks like a lot. So the best way to start is to take a first step, right? So let's go ahead and start by simplifying this. X plus h times x plus h. And I'm actually going to do it over here because you will run into this every time you do one of these problems. So we might as well do it in a place that's easy for you to find. So remember that x plus h squared is the same thing as x plus h times x plus h. So I'm going to distribute x times x is x squared. This is not the time for my pen to get jumpy. X times h, and you can write it hx or xh. It doesn't matter. I tend to go xh. I don't know why. Normally you go in alphabetical order. And then h times x is also xh or hx, either way. And then h times h is h squared. And then I have like terms right here, so I can combine like terms. So x squared, and I have two of these xh's, so 2xh plus h squared. And this right here is your best friend. Right, circle it, love it. Because every time you have this x plus h squared, you can just write this x squared plus 2xh plus h squared. So let's go ahead and simplify this a little bit. So x plus h squared, we just did. So I know that that is x squared plus 2xh plus h squared. Okay, so that's this part. Then I'm going to go ahead and distribute this -4. So -4 times x is -4x. -4 times h is -4h. And then I still have the plus 7. And then I'm still going to just keep this. X squared minus 4x. As you get more comfortable, you can start combining more than one step together. But I want to make sure that we are understanding the process first. This is all over h. Okay, so now I can go ahead and distribute this negative. So I'm going to do a couple things right now. I'm going to combine like terms where I can, and I'm going to distribute this negative. So since I'm distributing this negative, I no longer need all of these big brackets. So that just gives me x squared plus 2xh plus h squared minus 4x minus 4h. That first bracket is not changing, plus 7. Now I have minus x squared plus 4x minus 7. This is still all over h. So something very special here happens. I'm going to change my color. Things start to cancel. Look, I have an x squared and a negative x squared. So those can cancel. I have a negative 4x and a positive 4x. So those can cancel. And I have a 7 and a negative 7. So those can cancel. That's the whole point. You want that to happen, okay? So then from here, I'm left with 2xh plus h squared minus 4h all over h. Okay, and then the question is, okay, in the top, I do have a common value of h, right? I can take out an h in every single one of these terms. So I'm going to go ahead and do that. So h times, if I take out an h from 2xh, I get 2x. And then I take out an h from h squared, and I get h. And then I get minus 4. All over h. Well, what happens here is I have an h on top and an h on bottom, so those can cancel. So then my final answer is just 2x plus h minus 4. And that's it. So again, none of this math is anything that you guys can't do, right? It's multiplying, it's combining like terms, it's canceling, and it's factoring. So everything that you guys can do already. I feel confident in you. So what I want you to do is pause the video. Our last problem here, really try it. Use this example. Go back and look at this, or watch this example again if you need to, or whatever. But use this example to try to help guide you through that. And when you are ready, go ahead and hit play, and I will go over it. Okay, very last problem in section 1-2. I know it was a little long, but let's go through this doing the difference quotient. Okay, so again, first part here, all I'm doing is taking x plus h and plugging it in for x. Okay, so instead of x squared, it's x plus h squared minus, instead of 2 times x, it's 2 times x plus h, and then plus 9. So again, I'm just taking this equation right here, and whenever I see an x, I'm replacing it with x plus h. Then I have a minus. Then I'm subtracting f of x. Well, f of x is the original problem, so that's x squared minus 2x plus 9. And then the whole thing is over h. So lucky for me, I already know what this is because we did it up above, right? So I'm going to also distribute this at the same time. So we're going to kind of combine 2 steps in one here, but let's start on the left. So x plus h squared is x squared plus 2xh plus h squared, right? So we did it on the last example. And then I have minus 2 times x, so negative 2x, and then negative 2 times h plus 9. And then I'm also going to go ahead and just distribute this. So then minus x squared plus 2x minus 9 all over, don't forget the h on the bottom, all over h. So now hopefully we see things that we can cancel, right? The x squared can cancel, the 2x and the negative 2x, and then the 9 and the negative 9. Yes, okay. So then I have 2xh plus h squared minus 2h all over h. My next step here is to factor out an h. So if I take an h out, I'm left with 2x plus h minus 2 all over h. Here my h's can cancel. So that just gives me 2x plus h minus 2. And that's it. Whew! Okay, so please, even more important than ever, if you need help on something, contact me immediately, email me, send me a message on Remind. We can schedule one-on-one, or we can talk on Wednesday office hours, or whatever we need, okay? Or maybe I can just help you through email, but you have to reach out. If you need help on any of this, please let me know. Otherwise, that is it for 1.2, and I will see you guys later. Bye.